All right, welcome back to Mr. P Helps with Precal. This is Unit 3, Topic 2, Lesson number 3. We're going to be doing all the reciprocal graphs in this video for all the trig functions, that is. So this is a table that you should be very familiar with by now. I know I've done this in other videos, but I'm going to do it again because it becomes very valuable in graphing of the reciprocal functions. So 0 degrees is 0 radians. We know that 30 degrees is 6 pi over 6. This is pi over 4, and this is pi over 3, and this is pi over 2. So cosine of, so I'm going to start with the 30 degrees. So sine of 30 degrees is 1/2. Cosine is square root of 3 over 2. And tangent of 30 degrees is square root of 3 over 3. And then the reciprocal of that will be square root of 3. And the reciprocal of that would be 2. The reciprocal of this will be 2 times the square root of 3 over 3. All right, so 45 degrees is square root of 2 over 2, square root of 2 over 2. Once again, these are just ones that you should have memorized. The reciprocal of 1 is 1, and these are both square root of 2. So 60 degrees, that would be, cosine would be 1/2, reciprocal would be 2. Square root of 3 over 2 is going to be the 2 times square root of 3 over 3. And then the tangent of that is just square root of 3, which would be square root of 3 over 3 is the reciprocal. Now, 0 degrees. Now, if you think of a unit circle, you're at 1, 0. So the cosine is 1 and the sine is 0. Now, the reciprocal of 1 is 1, and the reciprocal of 0 is undefined. Tangent would be y over x, which would be 0 over 1, which is 0. And then the reciprocal of that is also undefined because 1 over 0 wouldn't make any sense. 90 degrees is right here, which is at 0, 1. So cosine is 0 and the sine is 1. Well, reciprocal of 0 is undefined and reciprocal of 1 is 1. Now, tangent would be y over x. 1 over 0 doesn't make any sense. That's also undefined. And then undefined, the reciprocal of undefined in this case would be 0. 90 degrees, cotangent would be 0 over 1, which is 0. Now, these two and these two are both undefined because they are the reciprocals of 0. Reciprocal of 0 is undefined because 0 over 2 getting flipped becomes 2 over 0, which is undefined. So that makes perfect sense. Both of these are at 0 degrees. So cosecant and cotangent are undefined when they're on the x-axis. So it's not just at 0 degrees, it's also at 180 degrees. And then both tangent and secant are both undefined at anything on the y-axis. So either at 90 degrees or at 270 degrees. All right, so that'll be important because this is going to be every 90 degrees, which is every pi over 2. And then these will be every 0 or 180 degrees, which is every pi. So they'll be undefined every pi amount of time, and these will be undefined every pi over 2. Now that really alone right there kind of explains why the graphs are going to look the way they do, which I'll come back to this later. So tangent function. So where is tangent undefined? That means we need to find the asymptotes. So where does it equal 0? So we just did tangent. Tangent right here was 0 at 0. So tangent was 0 at 0, and it was also 0 at pi, or 180 degrees, and also at 2 pi, so basically every pi. It was also undefined at 90 degrees, and as I mentioned before, every 90 degrees, so it's going to be just like this. Now, tangent, remember, is opposite over adjacent, which is y over x. So it's as a triangle gets taller, so it can keep having a taller length. So the height of the triangle could be much, much taller, and it keeps going like this infinitely, because technically one side of the triangle could be 1,000,000 and the other side can only be 1, and then it's 1,000,000 times bigger than the other. So technically it goes up forever, and then it just keeps repeating the same pattern as such. And the same with the negative side and here. Now, if we're going to do cotangent, then we know we're doing the reciprocal of this, which means that every time it hits 0 here, if you flip 0 over 2, it becomes 2 over 0. So now, wherever it was 0 here on tangent, then you know cotangent is going to be undefined. So they're kind of like, they're reciprocals of each other, but they're going to kind of look like opposites of each other. I'm going to do everything the opposite. So when this one was undefined, well, this one's going to be 0 because 2 over 0 becomes 0. or 0 over 2, which is like this. And then it's going to go down in the exact opposite direction, just like this. Okay, so tangent has its asymptotes at every pi over 2, and cotangent has all of its asymptotes at multiples of pi. So at pi, 2 pi, 3 pi, 4 pi, 5 pi, and so forth. All right, so now let's take a look at cosecant and secant, and how do we get these? Well, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So the first thing I'm going to do is graph my sine. So sine looks kind of like this, and cosine looks something like this. I'm just going to put the points here to make it so I don't make any mistakes. All right, kind of looks like that. So if I'm going to do the reciprocal, kind of like what I did with tangent, if sine of 0 is 0, then cosecant of 0 is going to be undefined, because 0 flipped upside down is undefined. So every time sine ends up hitting the x-axis, for cosecant is going to be undefined, which is all of these points. Now, 1-1s will actually hit, because if you flip 1-1 over, it stays 1-1, and therefore those points are going to be the same for both sine and cosecant. Now, all the points in between, this is where things get a little bit tricky. So this point right here is like it could be 1/1000th. Now, if you take 1/1000th and you flip it, it becomes 1,000 over 1. And 1,000 over 1 would be really, really high. So it could be 1/1,000,000th. It would be, flip it over, it'd be 1,000,000 over 1. So technically, it can go up infinitely, down to hit that point, and then up the opposite direction. So it's doing like the opposite of what this one's doing. But now you're in the negative. So now it's going to go down like this. This one does exactly the same thing here, and this one does the same thing here. So the positives are going to stay positive, the negatives are going to stay negative, because flipping it doesn't change a negative to a positive, which is the reason why it goes back and forth the way that it does. Now, the same idea happens for secant. So every time secant is 0, then you know that's an undefined spot. So this is undefined, and so is this, and so is this. And it's going to look exactly the same. Now, you're thinking this looks the same as this for the exact same reasons, but it's not. It's got different asymptotes. Yes, the graph does look very much the same, but it's not the same asymptotes, and it's not the same places that it's 0. So it's kind of like the same thing that's been shifted, which makes sense, because if sine is really cosine shifted that pi over 2 amount of time, then secant and cosecant are going to be shifts of each other as well. All right, so secant is undefined. I think I answered all these questions, actually. It's undefined every pi over 2, and cosecant is... it's undefined every pi amount of times, which matches back here. Remember, cotangent and cosecant are both every pi, and secant and tangent are every pi over 2. They're undefined, which is going to be one of the answers right here. Which functions have asymptotes at every pi over 2? So every pi was the cotangent and cosecant, and which functions are every pi over 2, and that would be tangent and secant. Okay, which functions have a period of pi? So that would only be tangent and cotangent, because if you look back at tangent and cotangent, so from here to here is half of pi, and here to here is 1 pi. So half a pi, so that's 1 pi total in width from asymptote to asymptote. Here to here is 1 pi, and then all of the others take 2 pi. So sine and cosine, as you know, they take 2 pi to complete one full cycle. So that's sine, cosine, and if sine and cosine do, then so do cosecant and secant, because these are just reciprocals of these. So obviously if these are every 2 pi, then so are these as well. So like you can see. All right. Tangent is blank along the interval. By the way, so there are asymptotes in between. So you're probably wondering, why is this one 2 pi? Because it's from bottom to top. This piece and this piece are not the same. So 2 pi is this distance. So all of this is one full cycle. So there is a break in between, but that is all one full cycle. Same thing goes for this. This is all one full cycle. So yes, it does take 2 pi amount of time for secant and cosecant to have one full period, one full cycle. Tangent is blank along each interval. So tangent is always increasing and cotangent is always decreasing. It's going down. And I think I've done it. I think that's all of the graphs. All right, thanks again for watching and have a wonderful day. If you can see me, hi, there I am. Nice to meet you. Thanks again for watching. Bye-bye.